Hi kids, today our topic of discussion is reflection from coordinate geometry from class 10. Just to recap what we did in class 9, we know when two number lines are perpendicular to each other intersecting at 0, this system forms our coordinate plane or Cartesian plane where any point P is represented by the help of an ordered pair. Just look over here. Suppose over here I take a point P, then this point P is represented by an ordered pair. See, 3, 2, where 3 is your x coordinate, isn't it? Which is also known as abscissa, and 2 is your y coordinate, which is also known as ordinate. And if you look carefully, abscissa is nothing but the perpendicular distance of the point from the y-axis, and similarly your ordinate is nothing but the perpendicular distance of the point from the x-axis. We all have done this. Now when we talk about reflection in physics, it's very simple. See, the same concept will follow over here. If this is your mirror, if there's an object A over here, then the image of the object will be formed. Suppose the distance is D. At a distance D unit behind the mirror, which means this distance and this distance is same. Okay, the same concept is followed over here. Now suppose the point P, 3, 2 is reflected in the x-axis. So your x-axis becomes your mirror, isn't it? And this point will be reflected over here. Okay, so if this is 2 unit, then over here, which is P dash, suppose the image is P dash, then P dash will be what? See, 3, -2, which means we just saw that, look over here, when a point P, 3, 2 is reflected in x-axis, then the coordinate of the image is 3, -2, which means the sign of ordinate is changing. Okay, so we can say that if a point P, x, y is reflected on x-axis, then P dash will be x, -1. This is number 1. Now, suppose we reflect the point P in y-axis. Suppose your y-axis is your mirror. Okay, for the sake of convenience, we have taken the point P in the first quadrant. You can take point P anywhere. Okay, now see, this is 3 unit. So over here 3 unit, isn't it? Here this will be, suppose, P double dash. Okay, so this is what? -3, 2, which means if the point P, see, P 3, 2 is reflected on y-axis, then the coordinate P double dash I've taken -3, 2, which means the sign of x coordinate changes, which means if we have a point P, x, y reflected in y-axis, then the sign of x coordinate changes, the abscissa. Okay, now one more thing. Okay, suppose the point P is reflected in a point, which means, suppose what I'm saying, this is your point P, this is your point O, origin, over here is origin, and it is reflected in origin, which means it is reflected in a point. Okay, which means this distance and this distance has to be same. Over here, same logic, which means this distance and this, so somewhere over here, so we'll get P triple dash minus 3 minus 2, isn't it? Which means if a point P, suppose 3 comma 2 is reflected in origin, in a point, in origin, then the image, the sign of both x and y coordinate changes, which means P, I've taken it triple dash, so P x comma y when reflected in origin, a point, then the sign of both the coordinate changes. Now these were very easy cases. Okay, simply when you're reflected in x-axis, you change the sign of y coordinate. When reflected on y-axis, you change the sign of x coordinate. Okay, and when reflected in origin, you change both the sign, x coordinate as well as y coordinate. Now suppose a point P is reflected on a line parallel to the x-axis or the y-axis, then what will be a situation? Now suppose we take a case where a point P x comma y is reflected in a line parallel to x-axis, in this case AB, which makes an intercept A unit on the y-axis. So definitely, first of all, the equation of the line AB will be y equals to A or y minus A equals to 0. This is the equation of the line. So what I mean to say, that what happens when the point P x comma y is reflected in a line y equals to A. I've taken the image as P dash alpha beta. Now we know this line AB bisects PP dash, and M, according to the diagram, is the midpoint. M is the midpoint of PP dash. Now take out the coordinate of M. The x coordinate is x and the y coordinate is A. Our main priority is to find alpha beta. Okay, now we know M is the midpoint of PP dash, which means this x will be equal to x1 plus x2 by 2, x plus alpha by 2, which means twice of x equals to x plus alpha, which means alpha equals to x. We got it. Similarly, A is equal to y plus beta by 2, which means 2a equals to y plus beta, which means beta equals to y minus 2a. Sorry, minus y plus 2a. Isn't it? So the coordinate of P dash, when a point P is reflected on a line y equals to A, which is parallel to x-axis, is x, which means the x coordinate does not changes, minus y plus twice A. The sign of y coordinate changes, minus y plus twice of A. What do I mean? Suppose a point, suppose 2 comma 3 is reflected on a line, suppose y equals to 4, then P dash, okay, y equals to 4 is a line parallel to x-axis. X coordinate remains unchanged. You change the sign of y coordinate plus twice of A, in this case, which is 4, which means P dash is 2 comma minus 3 plus 8, which means P dash will be 2 comma 5. Am I clear? Now let us see what happens when a point P is reflected on a line parallel to y-axis. Now look at this scenario when a point P x comma y is reflected in a line AB, which is parallel to y-axis. Suppose the coordinate of the image P dash is alpha comma beta. We know AB bisects PP dash into two equal halves, which means PM and P dash M will be same. First of all, the equation of this line. Suppose this line cuts an intercept A on the x-axis. So the equation of this line is x equals to A or x minus A equals to 0. Isn't it? Now look carefully. The coordinate of M, x is A and this is y. Isn't it? Now we know M is the midpoint of P dash P. M is the midpoint of P dash, which means I can say X is equal to X1 alpha plus X by 2, which means 2A equals to alpha plus X, which means alpha is equal to minus X plus 2A. Done. Similarly, Y is equal to beta plus Y by 2, which means 2Y equals to beta plus Y, which means beta equals to Y, which means the coordinate of P dash will be minus X plus twice of A comma Y, which means when a point P is reflected in a line parallel to Y axis, which is X equals to A, then the Y coordinate remain unchanged, the sign of X coordinate changes plus twice of A. So to summarize the entire thing, we have, if a point P X comma Y is reflected on X axis, the sign of Y coordinate changes. If a point X comma Y is reflected on Y axis, the sign of X coordinate changes. When a point X comma Y is reflected in origin in a point, then both the sign changes. Then the most important thing, if a point X comma Y is reflected on a line parallel to, suppose Y axis, X equals to A, then the coordinate, P dash, look over here, the sign of X coordinate changes plus twice of A comma Y. The Y coordinate remain unchanged. Similarly, if a point X comma Y is reflected in a line Y equals to A, where Y equals to A is a line parallel to X axis, okay, and cutting Y axis at A, then P dash will be the X coordinate remain unchanged minus Y plus twice A. So these are the most important thing which you need to remember. Okay. Now let us see one more point before we move to the exercise. Invariant point. Invariant point. Very important. What are invariant point? Point lying on the axis of reflection. On the axis of reflection is known as invariant point. The coordinate of the point, the coordinate of the point remain unchanged with respect to the axis of reflection. What do you mean by that? Suppose I take a point P, X comma 0. Now this point X comma 0 lies on X axis, and if we reflect this point in X axis, what happened? The image remains same because the sign of Y coordinate changes, so 0 becomes 0 only. So these point, which lies on the axis of reflection, when it is X axis becomes your axis of reflection, which lies on the axis of reflection and whose coordinate does not change after the reflection, are known as invariant point. Similarly, if you have a point, suppose you have a point 0 comma Y and is reflected on Y axis, similarly it will be same 0 comma Y. So these are your invariant point. The first one is invariant point with respect to the X axis. The second one is invariant point with reference to the Y axis. Okay. Now let us look at the sums from the exercise. Now look at sums from exercise 10, reflection. Okay. Number 6. A point P is reflected in origin and the coordinate of the image, suppose P dash, is 2 comma minus 5. Find the coordinate of P. Now we know that when a point is reflected in origin, both the sign changes, which means P should have been -2, 5. Then only when it is reflected in origin becomes P dash 2, -5. Isn't it? Now, part 2. The coordinate of the image of P when reflected in x-axis. Now we have P -2, 5. It is reflected on x-axis. So suppose P double dash. So the sign of y coordinate changes. Done. Now see 7 part 1. The point P 2, 3 is reflected in the line x equals to 4 to the point P dash. Find the coordinate of P dash. Look carefully over here. X equals to a. When a point P x, y is reflected in the line x equals to a, then P dash is what? You change the sign of x coordinate plus twice of a. A is over here 4, which means P dash will be, look over here, change the sign of x coordinate plus twice into 4, 3, which means P dash will be -2 plus 8 plus 3. Sorry. So P dash is 6, 3. Done. Clear? Now let us look at the next sum. Now look at 8 part 2. Find the image of the point P -3, -5 when reflected in the line y equals to -2. Y equals to a, which means the sign of y coordinate changes plus twice of a. So P dash becomes -3. The sign of y coordinate changes plus twice of a. So P dash is -3, 5 -4. So P dash will be -3, 1. Done. Isn't it? Now look at 9. The point P -4, -5 on reflection in the y-axis is mapped on P dash, which means the image is P dash. So y-axis. So when reflected on y-axis, we know the sign of x coordinate changes, isn't it? Now look, the point P dash on reflection in the origin, so this is now reflected in origin, is mapped on P double dash, which means the image is P double dash, which means both the sign will change. So this will become -4, 5. Find the coordinate of P dash. Done. P double dash. Done. Then look carefully. Write down a single transformation that maps P onto P double dash, which means if we want to go directly from P to P double dash, then where has the reflection taken place? See, -4, -5, -4, 5, which means the sign of y coordinate changes, which means reflection in x-axis. Okay, now let us look at the next sum. Now look at sum number 11. Find the coordinate of the image of 3, 1 under reflection in x-axis. So x-axis, it will be P dash 3, -1, followed by a reflection in the line x equals to 1. So again, the image is reflected in a line x equals to 1, which means P double dash. See, x equals to a. The sign of x coordinate changes plus twice of a. The y coordinate remains same, which means P double dash is -3 plus 2, which is -1, -1. Done. Now look at sum number 16. Plot the point A 2, -3, 2, -3, okay, B -1, 2, and C 0, -2 on the graph paper. Draw the triangle formed by reflecting these points in the x-axis. Are the two triangles congruent? First of all, A 2, -3 when reflected in x-axis becomes A dash 2, 3. Similarly, B -1, 2 when reflected in x-axis becomes B dash -1, -2. Now C 0 comma minus 2, and when reflected in x-axis becomes C dash 0 comma 2. Now we need to plot the point. Okay, first I'll plot ABC 2 comma minus 3, 2 comma minus 3 somewhere over here. A minus 1 comma 2, minus 1 comma 2 somewhere over here, isn't it? And C is 0 comma minus 2, which means over here. So when you join them, you get a triangle like this, isn't it? ABC. Now I'll do A dash. A dash is 2 comma 3, 2 comma 3. Over here you have got A dash. B dash is minus 1 comma minus 2, minus 1 comma minus 2. B dash is here. Okay, and C dash is 0 comma 2, so 0 comma 2 over here, C dash. So we'll join them, isn't it? Now, are these two triangles congruent? Yes. Why? Because during reflection, what happened? After reflection rather, the size of the side does not change. It remains the same. Hence, these two triangles can be proved congruent by side, side, side. Am I clear? Now let us look at the next sum. Now look at sum number 19. Very interesting. The image of the point P on reflection in a line L is point P dash. Describe the location of the line L, which means P. There's a line L. The image of this point is P dash. Now we know, suppose this is M, then PM, the perpendicular distance, and MP dash will be same, which means the line L is the perpendicular bisector of PP dash. That is the location of the line L. Okay. Now look at this, very interesting. Given 2 points P and Q, and that the image of P on reflection in y-axis is the point Q, which means if this is your y-axis, there's a point P which is reflected on y-axis and becomes Q. Okay, the point Q, and the midpoint of PQ is invariant on reflection in x-axis. Try to understand. Invariant, which means the coordinate does not changes. The coordinate of the midpoint of PQ does not changes when reflected in x-axis, which means the midpoint of PQ lies on x-axis, which means I can do like this. So this was PQ and this is x-axis, and the midpoint has to be over here. Okay, locate the x-axis. Very easy. This x-axis lies on PQ only. Okay, the y-axis is what? Perpendicular bisector of PQ. The origin is nothing, the midpoint of PQ. Done. Very interesting. Okay, now let us look at the next sum. Now look at this sum 22. Very interesting. A is minus 2 comma 4, B is minus 4 comma 2 are reflected on y-axis, which means y-axis and y-axis. If A dash, B dash are the images, so A dash will be what? Y-axis, so becomes 2 comma 4, the x coordinate changes, and B dash again becomes 4 comma 2. Find the coordinate of A dash, B dash. Done. Assign special name to A dash, B dash, B, and state whether A B dash equals to B A dash. Now look over here. First of all, let us plot A minus 2, 4, minus 2, 4, somewhere over here, isn't it? A dash is 2, 4, somewhere over here, A dash. B dash is minus 4 comma 2, minus 4 comma 2, somewhere over here, B. And B dash is 4 comma 2, so 4 comma 2 is here. So when you join them, I'm not wrong, you're getting an isosceles trapezium. What are you getting? Isosceles trapezium, isn't it? And they've asked, state whether AB dash, which means this, and BA dash, which means this, are of equal length or not. Yes, of course, they are of equal length. Why? Because it's an isosceles trapezium. AB dash is equal to BA dash. Okay, yes, they are equal. Now let us look at the next sum. Now look at this sum, 23. Use graph paper, they have told. The point 2, minus 4 is reflected, the point P rather. The point P, 2, minus 4 is reflected about the line x equals to 0. Now very important, x equals to 0 is nothing but the equation of y-axis. Am I clear? To get the image Q, so you get Q. So x equals to 0 is y-axis, so on reflection of y-axis it becomes minus 2, minus 4. Find the coordinate of Q, done. Next, the point Q is what? Minus 2, minus 4 is reflected about the line y equals to 0. Now y equals to 0 is nothing but the equation of x-axis, remember, to get the image R. So what will be R? The sign of y coordinate changes, isn't it? X-axis, so this becomes minus 2, 4. Find the coordinate of R, done. They told name the figure PQR, has to be a triangle. Find the area of PQR. Now first plot, P is 2, minus 4. So 2, minus 4, somewhere over here you're getting P. Q is minus 2, minus 4. Somewhere over here you're getting, isn't it? This is Q. And R is minus 2, 4. Minus 2, 4, somewhere over here. So this is your R. So when you join it, you'll get a triangle. And if you look carefully, it is a right angle triangle. Am I clear or not? An area of a right angle triangle is half multiplied by base into height. Now look carefully. This is your base, which is 2 unit over here and 2 unit over here. That's 4. And this is your height, QR, which is 4 unit over here, 4 unit over here. That's 8. So that's 16 unit square. That's the area. Done. Now let's look at the next sum. Now look at this sum, sum number 24. Very interesting. Use graph. The point P is 5, 3 was reflected in the origin. So when it's reflected in the origin, to get P dash, so P dash will be minus 5, minus 3. Both the sign changes, okay? Write then the coordinate of P dash, done. Then number 2. If M is the foot of the perpendicular from P to x-axis, find the coordinate of M. First plot, P is 5, 3. 1, 2, 3, 4, 5 to somewhere over here. This is your P. From there, I'll drop a perpendicular, isn't it? Which meets the x-axis, if I'm not wrong, at 5, 0. That's your M. That. Then if N is the foot of the perpendicular from P dash to the x-axis, first of all, P dash is minus 5, minus 3, somewhere over here. This is your P dash. Okay, I'll drop a perpendicular Pn. So N is what? Minus 5, 0. Okay, done. Find the coordinate of N. We got it, minus 5, 0. So M is what? 5, 0. And N is what? Minus 5, 0. Then they told find the area of PM P dash N, which means if you join it, just look over here. When you join it, you get a parallelogram. Okay. Now I can divide this whole figure into 2 parts. 2 right angle triangle, see, isn't it? For this area is half into base into height, and if you look carefully, area is half, the base is 10 and the height is 3, so that's 15 unit square. Similarly, for this triangle also, if you look, area is half into base into height, same, area is half into base is 10 and the height is 3 unit, so that's 15 unit square, which means total area or the area of the figure will be 15 plus 15, that's 30 unit square. Done. Now let us see the next sum. Now look at the last sum, sum number 29. The previous sums you can try on your own, okay? Use graph. P and Q have coordinate. P has coordinate 0, 5, which means 0, 5. P lies over here. Q has coordinate -2, 4, -2, 4, somewhere over here, okay? P is an invariant when reflected in an axis. Name the axis. See, P lies on y-axis, which means it is invariant with respect to y-axis. When you reflect this point in y-axis, the coordinate does changes. Okay, name the axis. Y-axis. Done. First part. Second part. Find the image of Q. Q is -2, 4. On reflection in the axis found above, so this is y-axis, the sign of x coordinate changes, so Q dash will be 2, 4. So Q dash is 2, 4, isn't it? Over here. Now look at the third portion. 0, k on reflection in origin is invariant, which means the image of this, suppose this was Z, the image Z dash will be same, isn't it? Write the value of k. Now k, see, when reflected in origin, both the sign changes. So if it was AB, it becomes -A -B. Okay, but over here 0, k remains 0, k, which means k has to be 0. If it is other value, it will change. Suppose I take 0, 5. So on reflection in origin, it becomes 0, -5. It's changing from 5 to -5. There's only one scenario in which it remains same, which is k is 0. Done. Now look. Write down the coordinate of the image of Q. So Q is -2, 4. Obtained by reflecting it in origin. So when reflected in origin gives you 2, -4, followed by reflection in x-axis. Again, x-axis, okay, Q double dash, the y coordinate changes, isn't it? Which means 2, 4. Done. Okay, so this is your last sum. Now in next video, we'll see some new chapter. Till then, take care.